In our last few videos, we have seen about NURBS, curves and how to analyze it. In this video, we will see multiple ways to create surface using Grasshopper. Grasshopper offers multiple ways to create surface using curves. With the different inputs, we can use different components to create surface. We will see most important components in this list to create surface. We will divide this video into two parts, so it will be simpler to understand. Let's look at simple ways to create surfaces using Grasshopper in the first part. Then let's get into little complex methods in the second part. Let's start. Before we understand the components, let's understand how Grasshopper treats the surfaces. As we have learned in the NURBS curve episode, we can define any point on the curve using parameter t when the curve is parameterized. Parameterized nothing but the overall curve will be defined in between 0 and 1. In between any points can be defined using parameter. Curves travels in one direction, but surface travel in two directions. Only one parameter is no longer enough. So surfaces use u and v parameter to locate any point on the surface. So when the surfaces are parameterized, it uses two domains, u, v. So it uses bidimensional domains or domain square. The horizontal line we can consider as u and vertical line we can consider as v. When you move this point, so using this u and v parameters, you can locate any point on the surface. And there is one more simple concept is that we can keep either one of the curve constant and move in only another direction. This concept is called isocurve. It either can be u isocurve or v isocurve. We can keep one domain as constant and move the other domain. Since it uses two domains, we will call this bidimensional domain or domain square. If the basics are clear, let's get into the interesting part. Let's create some surfaces. Extrude, boundary surface, edge surface, loft. The first one we are going to see about extrude. With a simple, very basic one, let's change this to perspective. Let's draw small rectangle. When you only have a curve and you just want to extrude, like if you are creating a massing model, you just want to create some boxes, then this is a simple way to create. As you can see the component, we need only two inputs. One is base, which is nothing but curve. The curve can be in any shape. And the direction. Double click on the canvas. Sorry, unit Z. You can see already it's extruded. Let's give some number, 500. I think this is very small, that's why it went so high. Let's keep 100. Very simple, right? This is a very simplest way to create surface. There are multiple extrude components are there. You can see that in surface, freeform, extrude components. So mostly we use extrude only. In some cases we will use extrude along. Currently we just extruded in the Z direction. Let's copy this. Let's draw the curve vertically. Let's connect this curve. So as you can see, you can move the curve along the path how you want. So when it's basic straightforward, you can use extrude component, or if you have the path and you just want to extrude along the path, then you will use extrude along. So this is good. Now let's say you want to cover this. Okay, you have 4 edges. In these kind of situations, what you will do? For this only, we use edge surface. For simplicity, I will just copy this. Just explore. Now you have 4 curves. You want to create a surface. So let's add the curves into Grasshopper. Copy, Control C, Control V. You can get copy as usual. Just connect these things. Add the curves one by one. So when you have 4 curves, you can use this edge surface component to create surface. This can be moved however you want. You can create the surface. But let's say you have more than 4 curves, then you use boundary surface. But the only condition is it has to be closed. It cannot be open like this. Open meaning these 4 curves are not connected, right? Let's say let's say I have multiple edges, but it is a closed loop. Then I can use boundary curves. As you can see, you can move any edges. You can create that surface. The final one is loft. So when you have different kind of sections, we can use this to create surface. So set multiple curves, loft. You just give the curves and create a surface. There is another input called options. In this, we can define how these things are connected. Let's connect loft options to this. So you can adjust all these things, like it is closed. These are booleans. If it is closed, the curve will come and connect to this. Let's see. And there are types. These things for now it is not required. Let's understand types. There are 6 various ways to connect these curves. One is normal, loose, tight, straight, and uniform. You can define these values using 0 to 5. Mostly the normal works for architectural works. Sometimes we will use straight. Also in some cases we will use also straight, which is 3. So let's define these values to 0 to 5. Connect. 0 is normal. So this is loose, where it will be much more smoother, but the accuracy will be less. And this is straight. So in straight, say if you're taking these 2 curves, it will connect straightly. Then these 2 curves connect straightly. And these 2 curves connect straightly. You can see the sharp edges. You cannot see in the normal. You can see the difference, right? And other types are also there, but we use mostly normal and straight in some cases. Let's summarize what we have seen in the video. We use extrude. When we have a curve and the direction, we will use base simple thing as extrude to extrude the curve. The second component is extrude along. When you want to extrude some curves in particular ways, like if you have a path to extrude, then you use extrude along. If you have less than 4 edges, you can use surface. If you have multiple edges but closed loop, then you can use boundary to create a surface. And when you have multiple section of the curves, you can use loft to create a surface. See you in the next video. Bye.